All right, thank you so much for joining us today. In the previous video, we talked about first order linear differential equation. And this video, we want to talk about separable. We want to talk about separable differential equation, right? So as we said, or as I said, we need to learn the forms. So you know that when we are talking about linear differential equations, it is a form. So we just saw that for us to solve a linear equation, we need to write it in the form of dy over dx plus gen of x, y is equal to h of x. What if we cannot write it in this form? Or let's say, what if the term here is equal to 0, right? So we have different ways of solving them, and we can use the idea of what? Separable differential equation. Now, when we're doing the linear differential equation, we were actually even using the idea of separable differential equation. So it's kind of a top up to that. Now, what we just need to know from here is with the linear differential or separable differential equation, the function, or we should be able to write the differential equation in this form. So I should be able to write it in the form of px plus q of y dy over dx is equal to 0. If I'm able to write it in this form, then I can say that the differential equation is said to be separable. It means that we can write it in that form. And if we do that, then we can write the differential equation in this form, right? The idea is that we can separate the function with the x one side, and then the function with y also one side. So you see that this is the function with y going with dy, and this is the function with x going with what? Dx. If we do that, then we can use the idea of separable method to solve the differential equation, as we did some in the first order linear equation. So now let me ask some question. Like, for example, we want to see if this is separable. And we said for us to write this in the separable form, then we should be able to write it in this form, right? So if we're able to do that, then we can say that, okay, the equation here, or this differential equation, is separable. So let's do that. We want to write it in the form of a function which is in terms of x plus another function which is in terms of y, dy over dx is equal to 0. So now let's write this and see if we can do that. So dy over dx is equal to sine x divided by 2y plus 6 plus 6. So now let's see what we can do. So the first thing that we can do is we can multiply this to the left. So when I do that, I'm going to have 2y plus 6 dy over dx is equal to sine x, right? Then what can I do again? I can decide to move this guy to this side, or I can also decide to move this guy to this side. Any of them holds. So when I move the sign, I'm going to have minus sine x plus 2y plus 6 dy over dx, which is equal to 0, right? And we can see that this is of this form, right? And we can see that now our p of x is equal to minus sine x, and our k of y is equal to 2y plus 6. Now the idea is that anytime your k of y should be in terms of only y and constant, and your p of x should be in terms of only x and constant. So let's assume that this one was, let's say, plus y, then this one will not be separable because the p of x is in terms of what? Y. So that is basically the idea with separable method. So now here we can conclude that therefore the equation is separable because we're able to write it in this form. Let's take another one. We want to also determine whether this is separable. So same idea, dy over dx is equal to x squared plus x squared y. So the idea is that we want to make sure that the y terms stand alone, and then the x terms to stand alone. So you can see that here the x and y is combined. So can we do something about it so that the y stand alone? Yes, we can do that. What can we do? This is the same as dy over dx which is equal to, I can factor x squared out and it will be left with 1 plus y. Good. Then what can I do again? Now remember, always the y term, the function with the y, which is the one which is with the dy over the x. So for me to get this function to be with this one, I need to divide this one by 1 plus y, divide this one by 1 plus y. So when I do that, I'm going to have 1 over 1 plus y dy over the x is equal to x squared. Like when I divide through by that. And this is the same as, let's say, x squared minus 1 over 1 plus y dy over the x is equal to 0. So what I did was I moved this one to the side. And we can see perfectly this is in terms of, or this is of the form px plus qy dy over the x, which is equal to 0. It means that p is equal to x squared and our k of y is equal to minus 1 over 1 plus y. So if we're able to do this, then we can use the idea of the separable method to solve this. We've done it before, so it's just nothing difficult. And yeah, let's go through the process to see the separable method that we were talking about. So this is basically what we just want to do. So for us to solve, then after we've shown that, okay, the differential equation is separable, then we need to write it in this form. So let me just see the process what is missing. So p of x plus k of y dy over the x is equal to 0. Now, how can you write it in this form? First, I'll multiply through by the x because I have the x here, so that the dx will multiply this. So I'm going to have the px dx plus k of y dy, because here when I multiply this one by the x will cancel the x. And when I multiply the x by 0, I'll get 0. Then for us to solve, then what we just need to do is we need to group the function as we learn from the linear order. After we are done finding the integrating factor, we need to group the x term on one side and then the y term too on the other side. So this is the same as p of x dx, which is equal to minus k of y dy, as shown here. So for us to solve, or for us to do the integration, after we've written the equation in this form, we need to also convert it to this form so that we can what? Integrate. So after I've done this, what I just need to do is integrate this with respect to x. So I'm going to just integrate this, and I integrate this with respect to y, which is already with them. I just integrate both sides here and that. So basically that's what I'm going to do. So this one is going to be integrate the left, which is the same as integrate the right, right? So this is like the process going through. And then what we just need to do is we integrate, and then we solve for y, and then we get our general solution. And if there is initial condition, and then we just use the initial condition to find our particular solution. Let's take some example. Let's practice and see what we can do. Now, we can find the general solution, and then we use the initial condition to find a particular solution. So now let's go through. The first thing that we need to know is we need to check if it is what? Separable, right? So since the question is not asking us to determine whether it is separable, when we just do it, we can just go straight through the method and we are done. So for it to be separable, we need to write it in this form. P of x plus k of y dy over the x is equal to 0. So let's do that. Now I have dy over the x, which is equal to 2 plus sine x divided by 3 y plus 1 squared. So basically the terms is like we have only x and we have only y, so we don't need to do simplification. What we just need to do is we multiply the y term to dy over the x, because the y term is with dy dx. So I'm going to have 3y plus 1 squared dy over the x is equal to 2 plus sine x. Then what I can do is here I can decide which one to move. Now I can just decide to move any of them, and then I'm done. So basically, we can see that this will be separable, because now when I move this guy to this side, I'm going to have minus 2 plus sine x plus 3y plus 1 squared dy over dx is equal to 0. So this is separable because this is of this form. The same thing here. So since it's separable, then we can solve, right? But the idea is that since the question is saying that we should solve it, then indeed, if it is separable, then we just need to go through the separable process, and then we are done. Now I will show you how to look at differential equation and know that, okay, this is what we need to, do, or this is the equation, or this is the method that we need to use as we are going through all the methods. So let's enjoy. Since now we have it in this form, then what we can do here is now we can now write it in the way that we can now do the integration. So I can write this one as so I'm just going back to this stage because I needed to show that it is separable. But if I don't need to show that it's separable, then what I need to do is now I just need to move this one to the right. So 3y plus 1 squared dy over dx is equal to 2 plus sine x. Then since this is y and this is x, I need to multiply through by dx so that I have y going with dy, and then also x terms or x values or functions going with the x. So this is the separable idea of like what we are talking about. So this is separable because we have the dy going with all y terms, and the x also going with all x terms. So when you're able to do this, then what you just need to do is just integrate both sides, and then you're just done. So I integrate 3y plus 1 squared dy is equal to, I integrate 2 plus sine x dx. That's all. So basically this is very simple. If you know how to do integration, it's very simple. Now I integrate this. I will show you one method. I'll show you another one. This one, when I integrate it, I'm going to have 3y plus 1, 2 plus 1 divided by 2 plus 1. But I'll multiply this one by times 1 because now when I finish, I need to differentiate y, and I'm going to get 1. But I'll just show you how to do that. Plus 1. Okay, this one will be 2 plus 1. And this is 1. So remember, we are integrating with respect to x. This one we are going to integrate with respect to, sorry, this one is y and this one is x. So now this one will be 2. So let me add something so that I talk about something here. So here, since I'm done integration, I'll add constant. Then this one too will be 2x plus. When I integrate when I integrate sine, I get minus sine plus, let's say, c2. So remember, when you are dealing with this kind of things, like, you need to be able to remember, when I differentiate sine, I get cos, but when I integrate sine, I get minus cos. Now, how did I get this? Now, this one, we can use integration by substitution. So let me do it quick so that you know how we had this. So here, I'm going to let u to be equal to y plus 1. So when I do that, it means that du over dy will be equal to 1, because when I differentiate y with respect to y, I'll have 1. Differentiate this will be 0. So du will be equal to dy. So from here, I'm going to have 3y plus this squared dy to be equal to integration 3. So now this y plus 1 is u. So I'm going to have u squared times dy is equal to du. So I'm going to have du. Is that right? And when I do this using the power rule, I'm going to have this one to be u squared plus 1 divided by 2 plus 1, and then plus c1. But what is u? U is 1 plus y, and this is going to be 3y plus 2 plus 1 divided by 2 plus 1 plus C1. So you see that doing substitution, this is how we are going to get. So the idea is that when you are very good with integration, you see that some of them you can just use your eye and then just do the integration without going to the substitution. We have some of them you can even, if you are dealing with integration by part, you can just do it off mind and then you just be writing them without writing all these things. So basically that is what I did. So I did substitution. So I just did substitution. So what I did was, since when I differentiate this one, I'm just getting 1. I just maintain this and then add plus 1 divided by this, like when I was doing this. And I do indirect substitution by letting u to be equal to this. So that is what you need to get if you didn't get that one. So now what can I do now? Now this is now going to give us 3y plus 1, 3 divided by 3 plus c1, or let me move c1 to the right. So equals to 2x minus cos s plus c2 minus c1. So this is going to give us y plus 1, right, to the power 3 is equal to 2x minus cos x plus, now one thing that you need to know is c2 is constant, this one too is a constant. A constant minus a constant is a constant. For example, 5 minus 2 is 3. 5 is a constant, 2 is a constant, and then the answer that we are getting to is a constant. So we can say that this is equal to c. So c2 minus c1 will give us a constant. So this is the general solution. They gave us initial condition, so we can also use the initial condition to also build the idea with finding the particular solution. So let's try and find particular solution. So they give us y of 0 to be equal to 2. So it means that y is equal to 2 and x is equal to 0. So let's do that. When I plug them in, I'm going to have y plus, no, y is 2. So 2 plus 1 to the power 3 plus, no, equals 2 times 0 minus cos, is it cos 0? Yeah, cos 0 plus c. So what are we going to get from here? We are going to get 3 to the power 3 is equal to, this will be 0 minus cos 0 is 1 plus c. And this implies that 3 to the power 3 is, I think, it's not 27. It's not 27. Yeah, it's supposed to be 27. And this will be minus 1 plus c. This implies that c should be equal to 28. Yes, so I think this is true. Is this true? Let me check it out. Yeah, this is true. I'm still thinking about it. Okay, so it should be 28. I think so. Okay, let me check something here. Okay, y is supposed to be minus. Okay, I think that was the reason why. So this one's supposed to be minus throughout. Please, let's check that one out. Okay, since we've used plus, let's maintain the plus, okay? So that it will not be like we are just changing everything, and just make this one plus positive. So you can solve it, you can resolve it by using the minus, okay? I use plus to do everything. So this is what you're going to get. So what was this one was the general solution. And then putting c inside now gives us the particular solution. So y plus 1 to the power 3 is equal to 2x minus cos s plus 28, right? And here we can make even y the subject. So y plus 1 is equal to 2x minus cos x plus 28 to the power 1 over 3, and y will be equal to 2x minus cos x plus 28 to the power 1 over 3 plus or minus 1. Good. So now this is the particular solution. Good. So it's kind of very simple. Try to group Lie terms with the functions with x with the x and the functions with y with the y. Let's take another example, okay? And let's do it. Now, looking at this one is already grouped, right? This is already grouped because basically we have like tan y, which is a function of y in terms of the y, and then we have the x to one side. So this one is already in the separable form, right? So all we just need to do is integrate left, integrate right, and then we are done. So integrate the x, integrate tan y dy. Now when I integrate the x, I'll just get that, like we have like 1 in front. So I'm just going to have x plus c1. Then when I integrate tan y, I'm going to have natural log of this. This is what I'm going to get, but I'll show you. This is what I'm going to get at the end of the day. Like when I integrate this, I'm going to have this. But if you don't know it, this is what you can do. We know that tan is the same as sine y over cos y, right? Then I use integration by substitution to do this. So I'll let u to be equal to cos y. Is that right? So when I do that, then I'll differentiate u with respect to y, which is going to give us minus sine y. So now let's do the substitution. X plus c1 is equal to integration sine y divided by cos y is u, so I'm going to have u. What is dy? Okay, let me make dy the subject here. So dy is equal to du over minus sine y, right? So when I make du the subject here, I multiply this one by this and divide through by minus sine y. So dy is du over minus sine y, and then the magic will happen. This will cancel this. So we are going to have minus 1 over u du, right? And then when I integrate 1 over u, since the degree of this one is 1, I'm going to have ln u plus c2. But the question is, now what is u? U is cos y. So this is going to give us minus ln of cos y plus c2. But the question is, somebody will ask, but this one we had minus cos y, and this one is sec y. It's the same thing. Remember trig identity. Sec y is equal to 1 over cos y. So when I plug it in, I'm going to have 1 divided by cos y, right? And then this is the same as cos y to the power minus 1. And then the minus 1 will come back here and now have this. So you see that it's the same thing. And the same thing here too, when I place this one by, I know that cos is the same as 1 over sec y. And when I do it, I'll come and have this one here. So basically that is what we just need to do. So as I said, your integration, you need to practice your integration so that you become very good at it. So now let's find for y. So I can write this one as, let me see what I can do here. Okay, so what I can do here is I can move the c to the other side, so get x is equal to minus ln cos of y plus c2 minus c1, right? Then let me just combine these guys together. I'll write this one as ln of cos y to the power minus 1. So I just move the minus to the up, and then I write this one plus c. I hope you understand now. Now, since I want to find y, and then I have this guy here, I need to pick the exponential function. So this, and then cos y to the power minus 1 plus c. So I pick e on both sides. So I'm going to have ex. Let me shift these guys to this side, which is equal to, now this is the same as e to the power ln cos of y to the power minus 1 times e to the power c. Remember, if I have indices, if the base are the same and I'm having something like a plus b, this is the same as e to the power a times e to the power b. So that's what I just did here. So this implies that this moves up here, and then we have something like e to the power x is equal to, now this will cancel that. So basically we are going to have cos y to the power minus 1, and then e to the power c is like, we know that this is a constant, so e to the power c is also a constant. So I can write this one as a constant, so I can write this one as k, because e to the power a constant, like let's say e to the power 5 will give us another constant, so I can make it k. So now this is going to be e to the power x is equal to 1 divided by cos y plus k, and then let's try and make cos y the subject. So what I'm going to do here is, let me multiply through by cos y. So when I multiply through by cos y, I'm going to have cos y ex is equal to 1 plus c cos y. Is that right, what I'm doing? Yes, that's right. So I'm trying to, basically I'm trying to make sure that I make y the subject. But when I do that, multiply through by cos, okay, I don't need to do that because I'll have y here. So what I can do is I can write this one as 1 over cos y is equal to e to the power x. Okay, so for it to be nice, what I can do is still let me maintain this, right? Let me still maintain times e to the power c, right? Oh, even it's multiplication there. Okay, so I think I did a mistake there. So let me just do what I was doing. So this one is like times c. So when I multiply through by k, I'll just have c. Good. Let me maintain this way. So this is what I did. This is supposed to be k. So basically this is yeah, so I said this one can be a constant and this one can be written as this, and then I just multiply through by cos y. So when I multiply through by cos y here and here, this one will be this, and then cos y now will be equal to k divided by ex, and cos y will be equal to k e to the power minus x. I think we can just even leave it in this form, basically, yeah. Or we can say that if we want to make y the subject, we can find the cos inverse so that y will be equal to, let's say, cos inverse of k e to the power minus x. Yeah, so now this is the general solution. This will be the general solution. Okay, they've given us initial condition, so let's try and find the initial condition too as well. They've given us initial condition. So let me just bring this guy here, and then also bring this guy here. Okay, this guy can be here. Good. So now we know that y is equal to cos inverse k e to the power minus x, right? That is the general solution. So now let's use the initial condition. Y of 0 is equal to 180. So y is equal to 180, and x is equal to 0. So let's do that. 180 is equal to, so from here, cos inverse of k e to the power 0. So let's reverse it back. Instead of finding the cos on the constant, let's reverse it back. So we are going to have cos 180 is equal to k e to the power 0. Now what is cos pi? I think cos 180 should be minus 1, I think. Yes. Yeah, minus 1, and this one will be k. So it means that k times 1 and k will be equal to minus 1. So since k is minus 1, we are going to have y to be equal to cos inverse of minus 1 or minus e to the power minus x. So I just plug in k, which is a minus inside this. Or we can even just leave it in this form, the way we just did this form, this one, so that we can just have something like cos y is equal to minus e to the power minus this. And this will be the particular solution. Okay, so something like this, which is very okay. So basically, that is how the West goes. Like, you should be able to know how to do the differentiation, and you'll be okay, and how to do the simplification too as well. Let's look at this one. This one, we want to look at how to separate this. So dy over dx, I can separate this one as minus x divided by 1 plus x squared times 1 plus y squared. Is that true? Yes. So I should be able to separate the y from the x. So this one, I just shift this one small to the side. Good. So if that's the case, then I can make sure I multiply through. So I can write this one as dy is equal to minus x divided by 1 plus x squared 1 plus y squared times dx, right? So I multiply this one by dx, multiply this one by dx. So now I have the x term with the x. I need to move this y term to the y. So what can I do? Since this one is multiplying, we divide 1 plus this on both sides. So we are going to have 1 divided by 1 plus y squared dy is equal to minus x divided by 1 plus x squared dx. So how to simplify the function too is very, very important. Right. So now that we have y function with dy, right, and then we have the x function too with dx, all we just need to do is integrate both sides. Now, as I said, your integration should be very good. As soon as I wrote this one, I saw that this will give me a tan function. This is tan, and this is natural log. How did I see that? Because I've been solving examples. I know how to do differentiations and those kind of things. Remember that when we were doing further calculus, we talked about, the inverse, or the when you differentiate a tan function, the inverse function, right? So when I differentiate tan inverse of x, this is 1 over 1 plus x squared. So if I remember this, then it means that if I'm integrating something that is 1 over 1 plus x squared, then I need to think about tan inverse. So you see that the left is going to give us tan inverse of y plus c1. So when I integrate the left, because I have 1 over 1 plus y squared, and I'm integrating it with respect to y, I'm going to get tan inverse. So these are some of the things that you need to know them off head, right? And then this too, I'm seeing it as natural log because I can factor minus out. This one I can basically use the idea of substitution, but I can also see that this is actually minus the natural log of 1 plus x squared, because I know that the idea is that anything that you get here, when you differentiate, you should get what is here. So when I differentiate this, I'm going to have this. When I differentiate ln of this, I'm going to have this. So basically that's the idea. But if you cannot see it from here, then on the right, we can use integration by substitution. So let's do that. Let u to be equal to 1 plus x squared. Du will be equal to 2x, right? And then what we need to do is, so basically the idea is that anytime you are doing it and you are playing smart 2, I didn't finish the smart approach that I was giving you here. So this is going to give us 1 plus x squared, right? But this one, when I finish, I need to multiply it by 1 over 2, because when I differentiate what is inside, I'm going to have, so this one 1 over 2x. No, it will cancel so the x will cancel the top there, the x here. So I'll just have it to be, so anytime I'm playing around it, I need to be very smart, like kind of like what I'm getting here. So I pick length of the down, but when I differentiate this, I'm going to have 2x, but the x will cancel the x, and then I have this. So let's use the substitution. When you are not good, or let me say you are going to get confused, you just use substitution and then you just go. So this is going to give us this, and then what is du will be equal to 2x dx, and dx will be equal to du over 2x. So it means that I'm going to have tan inverse of y plus c1 to be equal to minus x divided by, now 1 plus x squared is equal to u. Now somebody is asking, I'm sure somebody is asking, oh, but we also have 1 plus x squared here. Yes, we have 1 plus x squared here, but this one is having x. So it is not going to work out. This one is 1. If this one was 1, then this one could have been tan inverse of x. Good. Now times, what is dx? Dx is this. So we are going to have du over 2x. So as I said, you see that I was talking about some cancellation happening. So this is now going to give us minus 1 over 2, 1 over u du, right? So this cancel this. I have minus here. This is 1 over 2 factor out, and to be left with 1 over u. When I integrate 1 over u, since the exponent is 1, I'm going to have the natural log, which is ln of u plus c2. Then what is u? We know that u is equal to 1 plus x squared. So this is 1 over 2, the natural log of 1 plus x squared plus c2. And this is going to give us the tan inverse of y plus c1. So this is what we are going to get at the end of the day. So all we just need to do is we just group the y one side and then the other thing at one side, and we are done. So please, I'm just going to do, I think I even have videos on differentiation on my playlist. You can go and check some, but I'm trying to do differentiations, and then you can just learn it. Whether you are in level 300, 200, you can learn differentiation, because as you are taking maths, differentiation and integration is very important. So this is the same as tan inverse of y is equal to 1 over 2 natural log of 1 plus x squared plus c2 minus c1. So I just move this guy to this side. And we said we can combine this one and make it a constant. So plus c. So this is the general solution. We don't have initial condition. So this will be the end of this question. We just need the general solution, and then we are done. So I'll give you one try question, but this try question, open your eyes, and you should be able to figure out, like simplify it in a way that you have your y with dy and x is with dx. I just did this one complicated small for you to sit down and practice, like kind of the way of combining all the idea, and then you should be able to do this. So find the general solution. When you are done, use this initial condition to find the particular solution, and I will see who will get this one right. Put your final results in the comment section. See you in the next video, where we are going to talk about the idea that if, let's assume, now I cannot use separable, or the differential equation here is not separable, then what should I do next? See you in the next video.